Hey there. Welcome back to the deep dive. This is where we take that pile of sources you've sent our way and, well, we boil them down to the really key insights. The idea is to get you up to speed quickly, cut through the noise, maybe find some surprising stuff, and hopefully keep you hooked. Today, we're diving into something that feels, well, both super technical and really relevant to everyone. Artificial General Intelligence, AGI.
Yeah.
So, based on the material you've given us, we're going to dig into what AGI actually is, how people are trying to, build it, and the amazing possibilities, but also the serious challenges it brings up.
Yeah, and the sources you've got give us a great perspective. They trace this whole ambition back decades, actually. They get into the nitty-gritty technical details, and they really lay out both sides, this kind of utopian dream, and also the pretty significant risks people are talking about right now. And it's not just theory, right? This stuff really touches on, well, potentially everything about the future.
Absolutely. So let's kick off right there. We hear AI all the time now, chatbots, algorithms suggesting what you watch. How is AGI different? What is it?
That's really the core question your sources tackle first. Most AI we use today, that's narrow AI, it's brilliant at maybe one or two things, recognizing your face, playing a specific game like Go, maybe drafting an email for you. Super powerful, but limited, stuck in its lane.
Okay, so specialized.
Exactly. AGI, on the other hand, as your sources describe it, it's this idea, this hypothetical system that would have intelligence across a wide range of tasks. Think general cognitive abilities, maybe more like a human.
Human intelligence.
Sort of aiming for that benchmark, yeah.
Yeah.
We're talking about skills like solving problems it hasn't seen before, planning ahead, learning continuously from experience, understanding language naturally, perceiving the world through different senses and putting it all together. Some sources even bring up things like common sense, creativity, adaptability, stuff that current AI really struggles with, generally speaking. Of course, there's a lot of debate about, what exactly qualifies as AGI? Is there a checklist? Are today's systems even close? It's still very much up in the air.
Right, so it's that adaptability, that breadth, not just being a grandmaster at chess, but being able to learn anything almost.
Yeah.
And this isn't the same as artificial superintelligence or ASI. That really pops up too.
Good point. No, they're distinct ideas, though related. ASI is another concept your sources mention. It's often seen as what might come after AGI. Think of intelligence that doesn't just match humans, but wildly surpasses even the smartest human minds in, well, pretty much everything.
Right.
AGI is maybe about getting to human-level general intelligence, or maybe a bit beyond. ASI is, yeah, a whole different league, exponentially smarter.
Got it. Okay, let's step back a bit. This whole idea of building intelligent machines, it feels very current, very 21st century. But your sources show this dream or this goal, it goes way back. There's a whole history here with ups and downs.
Oh, absolutely. That's one of the really fascinating threads in your material. When AI started as a field back in the 50s and 60s, the pioneers, people like Marvin Minsky, they weren't thinking about just building calculators.
Yeah.
They were aiming for the big prize general intelligence right from the start.
Really? From the beginning?
Yeah. Minsky actually made this famous prediction in 1967, I think. Something like, within a generation, the problem of creating artificial intelligence will substantially be solved.
A generation.
That's bold. Incredibly bold, yeah. And this early optimism, it even shaped popular culture. Your sources point out how HAL 9000 from 2001, a space odyssey, his abilities were influenced by what AI researchers at the time were predicting for, 2001. Minsky himself was apparently a consultant on the film. They genuinely thought systems like HAL were plausible within a few decades.
Wow. I didn't know Minsky consulted on that.
Yeah, trying to make it seem realistic for the time frame, but then
Yeah.
reality bit. The sources describe it well. Researchers had grossly underestimated the difficulty building common sense, general reasoning. It turned out to be incredibly hard, way harder than they thought. And this led to what they called the AI winters. These were periods, especially in the early 70s and then again in the late 80s, where the funding just vanished. Confidence plummeted because these grand promises, like Japan's big project in the 80s aiming for machines that could hold a casual conversation, they didn't deliver. By the 90s, a lot of researchers actively avoided terms like human-level AI. They didn't want to sound like those wild-eyed dreamers from the past, as one source puts it.
Okay, so we had the initial hype, the crash.
Yeah.
Why the big comeback now? Why is everyone talking about AGI again? What changed?
Several things, according to your material. The actual term AGI got reintroduced and started gaining steam around maybe 2002, but the real acceleration, that came later. It was fueled by, massively more powerful computers, vast amounts of data becoming available thanks internet, and some really key breakthroughs in algorithms.
Like deep learning.
Exactly, especially neural networks and deep learning. That allowed for this renewed optimism. Suddenly, you see dedicated AGI labs popping up, universities offering courses, things like the first AGI summer school back in 2009. It marked a real shift back towards those original, really ambitious goals. And frankly, the performance of today's AI on certain tasks,
Yeah.
it's just staggering. Things we thought were impossible for machines just a decade or two ago. That's reignited the belief that maybe, just maybe, AGI is actually achievable, perhaps even soon.
Okay, this is where it gets really fascinating for me, learning from all those past struggles. How are researchers now actually trying to build it? What are the main techniques your sources talk about?
Well, at the core of a lot of the recent excitement, your sources definitely point to artificial neural networks and deep learning. These are systems kind of inspired by the brain's structure, layers of interconnected processing units or nodes.
Huh.
Their real power comes from learning complex patterns directly from enormous data sets. The deep part just means lots of layers, which lets them build up really sophisticated ways of understanding the data. That's crucial for things like understanding images or speech or text. It's a big part of the current optimism they can learn without needing explicit programming for every single rule.
Right, learning from examples.
Exactly. Now, historically, AI research kind of had these two big camps. You had the top-down approach, sometimes called symbolic AI. Think projects like Psych, which started way back in '84. The goal there was to manually encode human common sense knowledge using logic and symbols, building intelligence from rules, essentially.
Okay.
Then you had the bottom-up, or subsymbolic folks. That includes things like neural networks, focusing more on learning directly from raw data, from perception, like how a baby learns.
And these camps didn't always see eye to eye.
Not at all. There was this big philosophical debate tied to something called the symbol grounding hypothesis. How do abstract symbols, like words, actually get their meaning? Can you build real intelligence just by manipulating symbols? Or does it have to be grounded in sensory experience and interaction with the world? Your sources mentioned they were pretty skeptical of each other.
So where are we now with that?
Well, things are getting interesting. There's a growing movement towards what's called neurosymbolic AI, trying to get the best of both worlds, using the pattern-finding power of neural nets with the logical reasoning ability of symbolic systems, trying to bridge that old gap.
Okay, and what about specific technologies driving things today?
Right, so your sources put a huge spotlight on large language models, LLMs, built using something called the transformer architecture.
Like GPT-4 and similar models?
Exactly. Models like the GPT series, they're trained on just unbelievable amounts of text data. The transformer architecture has this clever trick called the attention mechanism, which lets the model figure out which words in a sentence are most important for understanding the context. That's key to how they generate such fluent, relevant text.
And they're getting pretty good, right? The sources mentioned exams.
Oh yeah, impressively good. They cite models scoring at human levels on really tough exams, the bar exam for lawyers, SATs, GREs. It shows they can synthesize and apply information from their training data in remarkable ways.
But they're not perfect. Hallucinations.
Big time. That's a major caveat your sources stress. They can generate stuff that sounds totally plausible, but is just wrong. Made up. They don't have true understanding or consciousness in the way we think of it. They're amazing pattern matchers, but they can confabulate.
Okay. Any other big approaches mentioned?
There's one completely different angle your sources touch on, though it's maybe more speculative right now. Whole brain emulation.
Simulating an entire brain.
Yeah. The idea isn't to design AI like a brain, but to literally scan a specific biological brain in minute detail and then simulate its structure and activity on a supercomputer.
Whoa.
If you could capture everything accurately the thinking goes, maybe you could replicate its intelligence. But, as your sources make really clear, the technical hurdles are just immense, monumental.
How so?
Well, first, we don't even fully understand the brain at that level yet. It's not just neurons and synapses. There are glial cells, other complex interactions, and the sheer computing power needed. It's astronomical, simulating billions of neurons, trillions of connections. One estimate mentioned needing to process something like 10 to the power of 14 synaptic updates per second for a human brain.
That's hard to even imagine.
Right. We're talking hardware way beyond what's generally available. So while LLMs and transformers seem like the most active path right now, brain emulation is still out there as this potentially different route, pushing neuroscience and computing limits.
That really puts the scale of the challenge in perspective. Okay, let's shift gears a bit. If AGI happens, if someone cracks it,
Yep.
what could it actually do? Your sources seem to suggest it could be revolutionary.
Oh, absolutely. The potential impact described is staggering, economically for starters. Your material throws out figures like AGI potentially boosting the global economy by, get this, $15.7 trillion by 2030.
15.7 trillion with a
Oh,
T.
yep. That number alone gives you a sense of the scale people are envisioning. And across different sectors, the benefits could be transformative. Look at healthcare. AGI could analyze huge data sets, patient histories, genetics, scans for faster, cheaper, maybe more accurate diagnoses than humans can manage alone.
Right.
It could help design personalized treatments based on your specific biology, massively speed up drug discovery by simulating how molecules interact, even assist in surgery or provide sophisticated elder care.
Okay, that's huge. What else?
Science and technology could see massive acceleration. AGI might help solve problems that are currently baffling us, complex quantum physics, maybe understanding dark matter, even proving tough mathematical theorems. It could optimize designs for new materials, for engineering projects, improve efficiency in renewable energy systems, untangle complex supply chains.
So accelerating innovation itself.
That's the idea, and in education. Imagine truly personalized learning plans, adapting in real time to how each student learns best. In the workplace, think about automating all the routine, repetitive stuff, freeing people up for more creative, strategic thinking. Your sources even float the idea that if the wealth generated is shared fairly, it could fundamentally change our relationship with work. Maybe reduce the need to work just to survive.
A universal basic income scenario.
That comes up, yeah. And then there are global challenges. AGI could analyze real-time data to predict natural disasters better, track pandemics more effectively, improve early warnings, even space exploration. Imagine autonomous systems managing complex missions, designing habitats, running simulations for colonizing Mars.
Wow. It really does sound like science fiction becoming reality. The potential is just enormous. But, and there's always a but, right? Your sources are equally clear that this power comes with some really significant risks and challenges. It's not all sunshine and roses.
Not at all. And the material you shared dives deep into these concerns. It's crucial stuff. Probably the most profound worry discussed is existential risk, the idea that AGI could potentially pose a threat to humanity's very existence.
Seriously. Like Skynet.
Well, maybe not exactly like the movies, but the core concern is there. You have prominent people in the field warning about it. At the same time, your sources show others pushing back, saying, look, we are nowhere near creating machines that can genuinely outthink us in the ways that would lead to that kind of catastrophe. It's a really intense debate based on different assumptions about how controllable this technology would actually be.
And controlling it is the key issue.
That's a huge part of it. The control problem, they call it. How do you guarantee that a super-intelligent system, especially one that might be able to improve itself over and over, stays aligned with human values? How do you make sure it remains beneficial and doesn't, go off the rails accidentally or otherwise? And that problem gets way harder if you imagine an AI arms race where countries or companies rush ahead, maybe cutting corners on safety or integrating AI into autonomous weapons.
Yeah, that adds a whole other layer of risk.
Definitely. And beyond those big existential questions, there are major societal challenges your sources highlight right now or looming very large. Wealth inequality is a big one. Stephen Hawking is quoted making the point that it all depends on how the economic gains are shared. Will it lift everyone up? Or, as he worried, if the owners of the AI lobby against redistribution, could most people end up miserably poor? Elon Musk is also mentioned, believing something like universal basic income might become necessary.
Okay, so economic disruption. What else?
Privacy and surveillance. AGI often needs massive amounts of data to learn. Where does that data come from? It raises huge questions about intrusive data collection. Think smart speakers, cameras, online activity. How do we protect privacy? Your sources mention techniques like aggregation, but it's a major concern.
Right, the data hunger of these systems.
Then there's bias. This is a really tricky one. AI systems learn from the data we give them. If that data reflects existing biases in society, racial bias, gender bias, whatever the AI, will learn those biases and can even amplify them.
You mean like facial recognition having trouble with certain groups?
Exactly. Or your sources cite examples like Google Photos mislabeling people, or predictive systems used in the justice system, like Compass, showing racial bias and predicting recidivism. And the scary part is this can happen even if you don't feed the AI sensitive data like race directly, because bias often correlates with other seemingly neutral data points. So AI trained on the past can end up perpetuating past discrimination.
Wow, it's deeply problematic.
It really is. Misinformation is another huge risk area your sources flag. We already see recommender algorithms pushing engaging but sometimes harmful content. But now, With generative AI, the ability to create incredibly realistic fake images, fake audio, fake video deepfakes, and fake text at scale, it's a potential nightmare for truth. Think mass manipulation, computational propaganda.
Making it impossible to know what's real.
That's the fear. And then there's the sheer power consumption. Training these huge AI models, running them in data centers, it takes an enormous amount of electricity. Your sources cite forecasts suggesting data centers and AI could double their energy demand by 2026. One estimate said U.S. data centers could use 8% of all U.S. power by 2030.
8%. Where does that power come from?
Exactly. It's driving talks with nuclear power providers, causing energy headaches in places like Taiwan and Singapore where data centers are booming. And all that energy use means a significant carbon footprint, contributing to climate change.
Okay, so environmental impact too.
Yep. And transparency, or the lack of it. For many complex AI systems, especially deep learning models, it's really hard, sometimes impossible, to know why they made a particular decision. The black box problem. There's a whole field called explainable AI, or XAI, trying to develop methods, things like shape or lime are mentioned, to try and peek inside and understand the reasoning, but it's a major challenge.
So we might not even understand how it works.
In some cases, yeah. Then there's the concern about market dominance. Will a few big tech companies that own the cloud infrastructure and computing power just solidify their control? And finally, your sources touch on the deep ethical questions if AI ever develops something like sentience or consciousness. There's debate now about whether LLMs could be conscious. If an AI were sentient, what rights would it have? How would we treat it? Huge questions.
It really sounds like getting to AGI is maybe only half the battle. Figuring out how to handle it, that seems just as hard, if not harder, based on everything in your sources. Okay, so we've covered a lot of ground in this deep dive thanks to your materials. We looked at what AGI actually means, how it's different from the AI we use every day. We traced that long history, the early dreams, the AI winters, the comeback. We dug into the key technologies like neural nets, deep learning, those powerful transformer models, and even brain emulation. And then we spent time on the two sides of the coin, the absolutely incredible potential benefits across medicine, science, productivity, really everything, and the very serious risks and ethical dilemmas, from control and bias to jobs, privacy, energy use, and even those fundamental questions about consciousness and existential risk.
Yeah, it's clear from everything you provided that this journey towards AGI, if it happens, is incredibly complex. It's not just about code and computing power. It's deeply tied up with lessons from the past, immense technical hurdles, and these really crucial decisions about the kind of future we want to build with such powerful tools.
So thinking about all of the Minsky's old predictions, today's LLMs, the worries about bias, the huge energy demands, it really leaves us with a critical question for you listening. Given everything we've unpacked from the sources, the immense potential upsides of AGI versus these very real, very significant dangers and challenges, how should we approach this? Is the priority just to get there as fast as possible? Or is it more important to move cautiously, ensuring safety, fairness, making sure the benefits are shared widely before we unleash something so powerful? What's the right balance? What really stands out to you after this deep dive?